It's division time. All right. Gets even better now. Now there's more exciting stuff to do. We just got done with multiplication. We're moving to division. Here's my little hint, my rhino hint. You need to rationalize the denominator in order to do anything. So example 8 is going to start us out with just rationalizing the denominator. After a while, they'll start clumping things together and we'll have to add. You'll see. It's just how the book has been running. Each section builds up to the next section. We're going to use this idea, and then in the next section, they'll start asking us to add and subtract, multiply, divide, all that good stuff. So division of radical expressions. We basically have 6 divided by this garbage. We want this garbage gone. We want our radicals gone. That's what they're saying. Now, to rationalize the denominator, if we had square root of 3, you know we'd multiply by square root of 3, it'd be gone, it'd be a 3. The goal is get rid of that radical symbol. However, we have a square root of 5 minus the square root of 3. So if we multiply by square root of 3, this one becomes 3, but this one becomes square root of 15. That doesn't do us any good. The key here is try to think back to special product rule for a perfect square minus a perfect square. You know that when you have a perfect square minus a perfect square, you have the square root plus the square root times the square root minus the square root. That makes the middle term go away. What's going to happen here is that middle term will be the only term with a radical symbol, but it's going to go away. The x squared means we're squaring this first term. Square root of 5 times square root of 5 gives us 5. Then we're squaring the second term at the end. Square root of 3 times square root of 3 gives us 3. That middle term is going to fall out. You'll see how we're going to do this. So think this route. It'll make the second piece fall out, go away. Whatever this is, this took me some getting used to. We take that and make it a quantity. Then, for what we're going to multiply by, for our quantity, we leave those two exactly the same, but we want to change this sign. That's it. That is it. Don't overcomplicate this. Write it exactly how they had it, but change the sign. That's all you do. That will make the middle term fall out. The key now is I like going this route, just writing it above. Then I make sure everything adds up. Whatever I do to the bottom, I do to the top. Same as any sort of fraction rule when we're trying to combine fractions. So when we're trying to make an equivalent fraction, we multiply to get the LCD. When we do that, whatever we multiplied the denominator by, we multiply the numerator by. So all you do is move this over, change the sign, and then write the same thing up on top. So what this becomes, I'll go this way and then I'll go down, is up top we have 6 times the square root of 5 plus 6 times the square root of 3. Down here, we're distributing. I'm going to do the whole thing. I'm going to try to jam it in. I'm going to skip a little bit. I'm going to say square root of 5 times square root of 5 is square root of 25. I'm going to go this route. Well, no, I don't want anybody to get lost. I'm going to keep it the same way I've been doing it. It's just going to take, I'll write it little, so you'll have to listen. Square root of 5 times square root of 5. Then I'm going to take my positive times my positive, square root of 5 times square root of 3. Then I'm going to take my negative times my positive, and I'm going to have a square root of 3 square root of 5. Then I'm going to take my negative times my positive and have a negative square root of 3 square root of 3. This proves the y. You don't have to do this whole step after this. You know rationalizing the denominator, square the first one and square the second one. They're going to go away because you're always doing the opposite. You need an opposite sign. Opposite signs end up being negative. So you know what's going to happen whenever they give you one of these. You don't have to do every step. You can skip a little bit of this. So what I end up with, I'll write it over here, 6 square root of 5 plus 6 square root of 3, all over, well, I have 5 here. Square root of 5 times square root of 5 is 5. That would have been thinking square root of 5 squared. A squared is 5. Plus square root of 15 minus square root of 15, gone. And then I know I have a minus y squared or b squared. In this case, my b or my y, whichever one you're using, would be square root of 3. Square root of 3 squared is 3. So now I have 6 square root of 5 plus 6 square root of 3 all over 2. It just so happens 2 divides in evenly. Gives me 3 square root of 5 plus 3 square root of 3. And I cannot combine those. So I am done at that point. Hopefully you see what I did. You could split this. You could say 6. We have time. The thought process here is 6 square root of 5 over 2 plus 6 square root of 3 over 2. You can combine those, but you can whittle them down. 2 goes into 6 3 times. 2 goes into 6 3 times. So this is my actual answer in lowest terms. If you're doing the test and you leave it over 2, I have to take a little bit off. Depending on how many points that particular problem's worth, I take a half point or a point off if you don't reduce all the way. So if you leave it over 2, it's not truly correct. You have to go lowest terms. Okay. Let's do one more. I think I only have one more. Yeah, we'll do example 9. There's only so much to know with this section. The end of section 6.4 with division. This is the rule. What we just did, that's all you're worried about. So example 9, all they do now is they give us more. They give us more on the top. Example 9 gives us this. So I'll use my red again. And again, think that's a quantity. So we're going to turn that into a quantity because you got to multiply everything. You don't want to just multiply by 2. I've seen that happen before. You know that is the same. You know that is the same. All you do is change your sign. Negative. Then up here, write it the same. Square root of 5 minus square root of 2. Double check that first. You don't want to do all the work and find out you wrote a positive up here by accident or a square root of 2 by accident. That's where most of our issues arise, is the initial step. We just write one thing wrong and then do the whole process and get a wrong answer. I don't want you to do that. So again, we have time. So I'm going to expand this all the way out instead of skipping. You can skip steps whenever you want, if you're confident. I have square root of 5 times square root of 5. And then positive, negative. So a negative. Square root of 5 times 2. Whoops. That's bound to happen at some point. I'm going to rewrite the whole thing a little cleaner. I have square root of 5, square root of 5, positive, negative, square root of 5 times 2. There you can see my square root of 5 in parentheses, 2 in parentheses, positive times a negative. Here, positive times a negative. So I'm going to have negative 2 times square root of 5. And then a negative times a negative is a positive, and I'll still do that. Even this 2 times 2 is 4. There's expanded on the top. Now on the bottom, we have square root of 5 times square root of 5. And then we have positive, negative. So a negative square root of 5 times 2. And then a positive square root of 5 times 2. Those will go away. And then a positive times a negative, 2 times 2. That's expanded all the way out. Now I just multiply everything together and then collect like terms and look for anything that cancels out. Square root of 5 times square root of 5 is 5. I have minus 2 square root of 5 minus 2 square root of 5 minus 4 square root of 5. Remember, 2xy. This is the same. This is negative and a negative, so it's x minus y times x minus y. So I have 2xy. And then I'm going to end up with a plus 4. There's my top. I know I can combine like terms, but I'm going to go step by step. Down here, I have my a squared. So square root of 5 times square root of 5 is 5. I have my plus minus, so they're gone. negative 2 square root of 5 plus 2 square root of 5 gone, minus 4. So there is my a squared minus my b squared. Remember, a squared minus b squared, they're different. Up here they gave us the same amount, so it's a minus b squared, which is different. Okay, so I'm going to combine 5 plus 4. That gives me 9 minus 4 times the square root of 5, all over 5 minus 4, which is 1. So I just write 9 minus 4 square root of 5. I believe that's the only, it's the only example that I wanted to do other than 8. So only 2 examples for the division, because it's kind of a lengthy process, but it's the same process. You just do this every time. Rationalize the denominator, the numerator will fall into place. To rationalize the denominator, keep your terms the same, change your sign, that's it. Okay, so pretty fun. I think we can all agree on that. I'll see you a little later for section 6.5.